So hey everyone, so again, our aim for today is how to graph polar circles and lines. And for you to do now, it's convert r equals 3 to rectangular form. And what is the graph of r equals 3? Okay, so there is a bunch of notes I want to go through today, so let me just go over the do now. All right, so first thing we're going to do is square both sides, right? Because, whoops, that's way too much. Yeah, so the first thing we're going to do is square both sides because, right, we need to get r squared, right? The formula that we know of is r squared equals x squared plus y squared, right? So we need to get r squared somehow. Now you might be tempted to like multiply both sides by r, you get r squared equals 3r. But the reason that that doesn't work is because 3r is an expression we're not familiar with, right? We can't do anything with 3r. So we're going to square both sides to get r squared, right? Yeah, we get r squared equals 9. And then r squared, you're going to replace that with x squared plus y squared. So you get x squared plus y squared is 9, and that's the rectangular form of this equation. And as for the graph of r equals 3, you can tell from this rectangular form, or if you remember from r equals 3 last week, that is a circle of radius 3 centered at the origin, right? And that's easier to tell from this, I guess, because we're more familiar with it, right? The center is the origin because you have x minus 0 squared plus y minus 0 squared technically equals r squared. So r is equal to 3. All right, so that's the solution for the do now. All right, give you a sec to copy this, and then we'll move on to the notes. All right, does anyone still need this? All right, not I'll move on. So let me just give you an overview of what we're doing today. So yeah, that was the do now, and then there's a definition of the graph of a polar equation, and then as the aim said, right, we're going to graph circles and lines. Okay, so first we're going to talk about circles with centers at the pole, and then we're going to talk about lines, and then move on to circles with centers on the axes. Okay, all right, so like our most fundamental polar graphs. All right, so for that, let me just get to the notes. And here's the first slide. Okay, so here we have the graph of a polar equation, r equals f theta, is the set of all points r theta in the polar coordinate plane, where r comma theta is a solution to the equation r equals f theta. Okay, so I know that's really wordy, but it's a really simple idea. It's just saying that polar coordinates can be used to write functions as well, right? So, Cartesian coordinates, we had x, y. So a function like that would be like f of x equals x squared, right? Here we have r and theta, but just note that the dependent coordinate here is r, right? So like you plug in theta, you plug in the angle into the function, and then you get out r, okay? But the thing that's different from Cartesian coordinates is, x, y, x is the independent variable, right? Y is the dependent variable. Here, r is dependent, right? That's the output. But theta is the independent variable. So the order is like switch, right? X, Y, x is independent. Here, theta is independent. So yeah, just keep that in mind. But yeah, I just wanted to include this definition to point that out, right? So you can write a function in terms of r and theta like this, r equals f theta, and then note the coordinates, right? Theta is independent. That's what we plug in. Okay, does anyone still need the solution here? Or sorry, not the solution, the definition. Okay, if not, I'll move on then. All right, this is the next set of notes, just circles centered at the origin. All right, we've seen this last week, but yeah. Can someone read the slide here?
The graph of the equation r equals a is a circle of radius a centered at the origin.
All right, very nice. Thank you for that. Well, note that it's absolute value of a, so like it's going to be positive. So I know like r can be negative and positive in the polar coordinate system, but here, since we're talking about circles, we designate the radius to be the absolute value of a. So we want it to be positive. Right, but we could have an equation of r equals -3, right? But the radius there would still be +3, right? So r equals -3 is still a valid equation in the polar coordinate plane. Circle of radius 3, right? But yeah, so radius would be +3. And yeah, in red, that's the equation from the do now, right? R equals 3. Okay. All right, anyone still need this slide? All right, I'm gonna move on then. All right, here's the next example. Well, don't copy this yet. This is actually talking about this example, but we're gonna work on convert theta equals pi over 3 to rectangular form, and then what is the graph of theta equals pi over 3? And as you can see from this heading, right, it's gonna be a line that passes through the origin. Okay, so let me scroll up for the solution. Okay, so first step is we're going to take the tangent of both sides, and we actually saw an equation of this form like last week, like we saw like theta equals pi. In that case, we actually just plotted the points, but you could have done the tangent of both sides also. That's what we're going to do here. Okay, so tan theta equals tan pi over 3, and then we know that tan theta is equal to y over x, right? That's one of the formulas from last week. Tan pi over 3, on the other hand, that's square root of 3, right? Tan is 60 degrees. So we're gonna get this, and then you cross multiply, you get y equals square root of 3 x. So that's our line, right? Slope is square root of 3. Okay. Graphically, this is the set of all points whose angle is pi over 3. Okay. And that will look like this, right here. So the angle is pi over 3. And in general, right, the graph of the equation theta equals this Greek letter phi. This is that's the Greek letter for phi, is a line through the origin that makes an angle of phi with the polar axis. Okay. So yeah, bottom line, just please copy this. All right, does anyone still need this? All right, otherwise I'll move on to the next example. Okay, so this is the next case we're going to look at. So again, first thing was circles with centers at the pole. Next was lines, which we just saw. And then last case today is circles with centers on the axes. Okay, so to sketch a polar curve whose graph isn't as obvious as the ones in the preceding examples, we make a table of points and plot them. Okay, so we're going to sketch the graph of the polar equation. R equals 2 sine theta by plotting points with theta being between 0 and pi. Okay, so yeah, here's my table of values. So it's going to be 0 to pi, right? Theta, remember theta is the independent variable, and then r is what we get out. Okay, so plugging 0 into 2 sine theta, we get 0. Right, so 2 times sine of 0 is 0, we get 0. Next we have pi over 6. Sine of pi over 6 is going to be, so sine of 30 degrees is 1/2. So we get 1/2 times 2, that's 1. Next we have sine of pi over 4, which is sine of 45 degrees. That's root 2 over 2. So we get root 2 over 2 times 2, which is root 2. And so on and so forth. And then for these, yeah, this is what you're going to get for these values. Square root of 3, 2, square root of 3, root 2, 1, 0. Note that it is symmetric, right? Which makes sense, right? Because sine, it is symmetric in that way, right? So sine of pi over 3 is equal to sine of 2 pi over 3, right? Quadrants 1 and 2, right? Both positive root 3. Yeah, after this table, I just plotted this points on this paper here. I don't have a polar graph paper with me, but if you have a printer, the classwork worksheet that I post on Google Classroom is, that's polar graph paper right there, or there's a grid right with polar graph paper. I don't have a printer myself, so I just had to plot these points on regular paper. But no problem. Like it was a little more difficult just because like you have to like eyeball everything, but still doable. So you have 1 and 2 here for your radii, and then first point was 0, 0, which is here. Then we have 1 comma pi over 6, so radius of 1, angles 30 degrees. Next you have 45, root 2 pi over 4. Now for these radicals, you have to keep in mind that the decimal values are like, 1.4, 1.73. So that's easier to plot if you write in decimals, because that gives you like a reference for where it is between 1 and 2. All right, so that'll be like 1.4, 45 degrees, and then root 3 pi over 3, that's 1.7, 60 degrees, that's here. And then 2 comma pi over 2, that'll be here, right? And then plot the other 3 points, you get the circle here. Okay, so yeah, just make a quick sketch of that in your notebook. Note that the pole is right here, right? But the center, as are right here, is going to be 1 comma pi over 2. That's located right here. Okay, so there's 1 comma pi over 2. That's the center, and the radius is 1, as we see, right? So yeah, distance from the pole to this point is 1. I decided to cross this out. You don't have to mind this question. It's the question I could ask you, but yeah, I won't go through it today because I want to get to the next slide. All right, is anyone still copying this table or this graph here? Please type in the chat or speak up. Okay, if not, then I'll move on to what I believe is the last slide of notes. And then the classwork. Okay, all right. Yeah, here's the last slide of notes, just summarizing that graph that we just drew, r equals 2 sine theta. So circles with centers on the axes. Let me zoom out for this. All right, this is the last set of notes. Okay, so circles with centers on the axes. Can someone read this slide for us?
Okay. Circles with centers on the axes. Graphs of equations of the form r equals a sine theta are circles with the radius 1/2 absolute value of a, centered at the point with polar coordinate a over 2, pi over 2. For r equals a cosine theta, the radius is 1/2 absolute value of a, and the center is at a over 2, 0.
All right, thank you for that. So yeah, just to summarize, there's another type of circle that you'll see. Right, so first type of graph we saw today was the circles with center at the origin, right? That's like really simple. It's like r equals 3, right? So the center would be the pole, and then radius is 3. Here, the centers could be on the the vertical axis and the polar axis. Okay, as you see here in purple, there's a purple circle here. That's one example, and then there's a green circle here. That's another example. That'll be r equals a sine theta, and then here would be r equals a cosine theta. So yeah, r equals a sine theta, the centers are on the vertical axis, which makes sense because sine is a vertical function, so to speak. Like, in physics, like the vertical component is sine theta times the vector. Same thing for like a cosine theta, right? That the center is on the polar axis, so horizontal. Yeah, and these are the stats for the radius and the center. But yeah, this is actually especially useful because if you want to graph something like a circle like this really quickly, you just identify the circle, the center, I mean, of the circle, and then the radius also from here, and just draw a quick sketch. I would just plot the center, and then draw a circle with radius 1/2 absolute value of a, rather than having to go through the entire table, which is exactly what I did for the homework questions for this lesson. All right, but yeah, does anyone still need this slide here? All right, not then I'll move on to the classwork. So we have 4 minutes left, so we don't have time to work on it on our own, but let me just go over the solution then. All right, so here is the worksheet. Okay, so I'll show it really quickly, and then we'll go through the solution. Okay, so here's the graph, r equals 2 cosine theta. Well, here we're prompted to, complete it using a chart. Same thing we did with the sine theta function. And then there's a polar grid here. And part B is convert the equation to rectangular coordinates and then identify the function. Okay, so I'm going to jump to the solution for that. Okay, so here's your chart. Okay, so 0 to pi, and then you plug in these angles into this function. You're going to get 2, square root of 3, square root of 2, 1, 0, -1, negative root 2, negative root 3, -2. Okay, so for now, just copy down this table in your notes, or if you have the classwork worksheet, you can write it on there. Is anyone still copying this table down? I mean, I was gonna plot the points, but just so you don't have to like focus on two things at once. Okay, so let me just show you really quickly how to plot some of these points. So, after you make this table, you graph 2, 0, which is here, right? R is 2, angle is 0, that's right here. And then just note here that the lines here are marked off by 15 degrees apiece, right? So there's 15, 30, 45, 60, 75, 90. Okay, so just keep that in mind. First point, second point is root 3, comma pi over 6. And as you saw earlier, right, square root of 3 is about 1.7. 1.7, the angle is going to be 30 degrees. So that's right here-ish, right? Between 1 and 2, closer to 2. Yeah, angle is 30 degrees. Now, this is precise because there's a Desmos, right? So, but, if you're graphing by hand, you don't have to be like super precise. Just between 1 and 2, closer to 2. Next value is square root of 2. That's about 1.4, 1.4, comma 45 degrees. That'll be right here. And then we have 1, comma pi over 3. So that's radius of 1, 6 degrees. That's located right here. And then I'll graph one more, 0. So r equals 0, that automatically places us at the pole, right? So it doesn't matter what the angle is, right? The r equals 0, so it'll have a radius of 0, which places us right there. Okay. But yeah, the other points would be similar, right? Let me do one. -1, 2 pi over 3. So -1, we start on the left, right? And then 2 pi over 3, that's 120. So that's 90, and then another 30. That'll be located right here. So this point here is -1, 2 pi over 3. And then you graph the other ones, right? And then connect the dots, make a circle. Okay. All right, so that's your graph for part A. Really quickly for part B, we were tasked to write this in rectangular form. So just like we did last week, I'm going to multiply both sides by r. We get r squared equals 2r cosine theta. R cosine theta, we can rewrite that as x. And then r squared, we replace that with x squared plus y squared. Subtract 2x from both sides, we get this. Complete the square for x. We get x squared minus 2x plus 1 plus y squared equals 1. Right, just adding 1 on both sides. And then you factor. Okay, so you get x minus 1 squared plus y squared equals 1. So this is the equation in rectangular form. And then the last part of this worksheet was to identify the graph. So it's a circle with center 1, 0, right? X coordinate 1, y coordinate 0, center 1, 0, and radius 1, right? 1 is r squared, so r would be 1. All right, but yeah, for closing announcements, there's SGI today, per usual at 2:47. Drop by if you have questions. But yeah, if you're done copying this and you have no further questions, you're free to go. And I'll see you all tomorrow. All right, take care.
Have a nice day.
All right, thank you, you too.
Thank you.
You're welcome.